Hypothalamus Artificial Intelligence, HI, presents a summary of 50 years of experience in decision-making artificial intelligence making advanced mathematical models. HI is a spin-off company of two LATAM companies, PDC Ingeniería and Decision, Ware. Products and experiences in the electricity sector. The models developed by HI for electricity wholesale systems and markets are dispatch models, economic perfect dispatch, economic regulated dispatch, Carnot-Nash equilibrium dispatch, electricity and gas dispatch, and unit commitment. Complementary models, electricity dispatch and financial analysis, maintenance of regional national grid, electricity supply chain design, and risk management, and energy trading and risk management. Project, electric and gas system and market dispatch for Peruvian transmission expansion plans. Challenge, to develop an integrated electricity and gas dispatch model to support the optimization of the national plan of transmission in Peru. Solution, design and implementation of a set of mathematical models that includes simulation of simultaneous optimum dispatch of electricity and natural gas systems, and the evaluation of multiple expansion uncertainty scenarios, to build Pareto curves that support the selection of a robust expansion plan. Result, MODPlan, a long-term stochastic parallel optimization model that includes simultaneous optimum dispatch of electricity and natural gas systems. The model was linked to the Excel environment used by the end user. Since 2014, MODPlan has been the official model, by law, used by ISO of Zine, to carry out transmission expansion plans. Project, Natural Gas System and Market Dispatch Model. Challenge, to implement a mathematical model to simulate the transportation production and consumption of natural gas that describes its processes of supply and demand. Solution, design and implementation of an optimization model that includes the following types of nodes. Production fields. Consumption center, natural gas demand nodes discriminated by demand sector, among which are industrial, vehicular, electricity generation, commercial and residential, and ports, terminals, that can receive and or send LNG. It is associated with liquefaction and or regasification plants. Result, MODPlan gas, is a long-term stochastic parallel optimization model that simulates the optimal dispatch of LNG systems. MODPlan, power and gas, by law, it is the official model in Peru, for the analysis of the expansion plan of the Zine transmission network. Project, Electric System and Market Economic SSDP Dispatch. Challenge, the Superintendents of Public Domestic Services of Colombia, SSPD, hired HI in 2010 to implement a system of models to simulate joint operation of the electricity market and the gas market in Colombia. Solution, implementation of a mathematical model that simulates the economic electricity dispatch of the national transmission grid in Colombia. The model include the gas transport system, the production and handling of GNL by liquefaction and regasification. Result, MODSE, is a version of high power to support the simulation of the electricity and gas transmission grids in Colombia. The model was customized to include data known to the SSPD as the system supervisor, for example, contracts between agents. MODSE was developed in C++ as a SaaS service in the cloud. Project, Decision Support System, DSS, to supervise the wholesale market of electricity. Challenge, to develop a DSS to surveillance activities for the electricity and natural gas sectors. Solution, design and implementation of the DSS that included the following models: electricity and gas dispatch, competitive electricity market equilibrium, real dispatch of the interconnected system considering the long-term contracts of purchase-sale of natural gas and electricity, and financial statements of the electricity generators considering the real dispatch, and an Stackelberg market economic model, with two types of agents, price makers and price takers. Result, a DSS that integrates the models required by the supervisor, based on high power. Project, optimization of the health of power industrial assets, using PHM framework. Challenge, development of a technical document, specialized in the management of the health of industrial assets in the electricity sector. Solution, study of methodologies and technologies based on artificial intelligence and mathematical programming for the optimization of the management, operation and maintenance of industrial assets. Result: elaboration of the technical document. Project realized in Alice with Rena, an Italian consulting company. Research and development project, multi-state Kalman filter, applied to stream flow forecasting. Challenge: in 1977, HY's scientific director completed his research in multi-state Kalman filter, applied to stream flow forecasting. Solution: design and implementation of the multiple state Kalman filter, MSKF, that it is a methodology that allows to combine the process of determination of possible Markovian states where can be a system with two response functions identified by Kalman filter for each of the possible states of the system. The selection of the probability of the Markov state in which the system is located is determined based on a Bayesian inference model. Result: the model was applied to forecast stream flow in the basin of the Caroni River in Venezuela. Products and experiences in the oil and gas sector. Oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way to management the planning of the supply chain with a holistic vision. The design of HY Oil AWO was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the hypothalamus of an oil enterprise. The current computational power allows to model detail the supply chain, considering individually all the systems that compose it. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. Large-scale optimization and artificial brains. One of the fundamental ideas of the artificial brain is the atomization of the system, bottom-up approach, to integrate multiple mathematical models, using the framework of large-scale optimization methodologies, like multi-level Bender's theory, and Lagrangian relaxation. HY Oil meets all the software solutions developed by HY, in different areas of application of mathematical optimization models, oriented to planning and to scheduling operations, in different business of the petroleum product supply chain. All models may be part of the hypothalamus of an oil organization. Oil fields production optimization. Model. Challenge: to implement model to optimize the production process in onshore oil fields, including industrial services plants. Project: oil fields and smart grids optimization. Challenge: to develop a model for redesign the energy supply system of oil onshore fields. Solution: design and implementation of a stochastic optimization model that includes aggregated simulation of oil field operations, and design of the topology and capacities of the smart grid to supply electricity to support operations. Result: deliver the models to the client, a consulting company, who implemented the models for its end-user client, a LATAM oil company. Refined petroleum production and energy services planning model. Challenge: to develop an integrated production and industrial services optimization considering that the optimal management of power of industrial systems implies a holistic position oriented to integrate the production planning of goods with industrial, energy, services that are consumed in the production plant, and finally integrate it with possibilities of self-production and negotiation of this energy in the energy markets. Solution: design and implementation of an optimization model that simulate the production process, and simulate industrial services process, like boilers, pumps, turbines, electricity plants, collector, compressors, etc. The approach considers that industrial processes have variable speed, and that the power consumption as a function of the speed is nonlinear, it is exponential. Project: real-time optimization of the operations in oil pipeline systems. Challenge: to design and implement models for real-time optimization of the operations in oil pipeline systems. Solution: design and implementation of a set of optimization mathematical models, that include the use of pumping stations, and the simulation of operating conditions, based on detailed models of the hydraulic behavior of the system components. The solution includes large-scale optimization methodologies. Result: real-time operations model to dispatch the batches of products, heavy crude oil, in the pipelines. In test case runs, it was verified that the difference between minimizing energy consumption and minimizing the total cost of operation can be of the order of 20%. Project: strategic planning for the exploitation of natural gas fields. At the end of the last decade of the last century, Oil Express, a global natural gas company that operated several natural gas producing fields in multiple countries, asked HY for support to define a natural gas field exploitation planning strategy, using highly complex mathematical models, to analyze the entire decision-making environment. The challenge was to develop a model that supported the decision-making regarding the exploitation of natural gas field and its impact on Oil Express finances. Products and experiences in regional planning and public management. The artificial hypothalamus is the evolution of DSS under the Industry 4.0 revolution, and it is the integration of the methodologies of artificial intelligence and mathematical programming. HYPO meets all the software solutions developed by HY in different areas of application regional planning optimization. The models developed by HY for regional planning are land use urban planning, land use urban, and rural planning, regional economic computable equilibrium, location and use of social infrastructure, regional food supply planning, public project management support, and water resources planning and scheduling. All models can be part of the hypothalamus of an organization oriented to regional planning. Project: holistic regional planning optimization. Challenge: to develop a model to support the territorial planning plan of the city of Medellin, to evaluate the impact of land management policies. Solution: design and implementation of a spatial techno-economic input/output model to simulate the future land use, based on maximizing partial social surplus, incorporates the following subsystems: business, housing, public space, employment, and transportation. Result: the model probed that, for the steady-state case, the non-optimality measures were persons relocation, fraction of the relocated population, equal to 62%, and economics relocation, fraction of the relocated economic activities, equal to 82%. Research and development project, urban and rural planning optimization. Challenge: to develop optimal development plan for the land use in conurbated areas. Solution: HYPO FOSSUM was developed as part of a HY-RAND, research and development, process oriented to the integrated modeling of the urban and rural connected regions. It integrate the experience of HY and urban regional planning, master plans of resources for cities with FOSSUM, forest and agricultural sector optimization model, a dynamic model of nonlinear programming of the U.S. agricultural and forestry sectors that describes the dynamic allocation of rural land over time, as a result of competition from forestry activities with agricultural sectors. Result: implementation of prototype version of the model for a LATAM city. Regional economic computable equilibrium model. Challenge: to model the economy in a conurbation, considering that cities correspond to a region within a country, so the study and modeling of its economy must be analyzed in the light of this inevitable peculiarity. Solution: design and implement a model considering that the country's economy is simply the starting point for modeling the region, but it must be adjusted to consider the economic relations derived from its regional character, which implies relations with other regions that allow the free flow of products, people, and production factors. Result: implementation of a prototype model to simulate the multi-regional economy, based on a multi-sectoral equilibrium model. Location and sizing of social infrastructure model. Challenge: to implement master plans for the different facilities of the city. Solution: design and implementation of a DSS that integrates mathematical models to optimize several master plans that are part of the city development plan. These models include food supply, solid waste processing, public space, health facilities and educational buildings. Result: the DSS was delivered to the end user who must implement the information system to use the models. Solid Waste Transportation Model. Challenge: to implement a DSS for solid waste transportation. Solution: design and implementation of a set of optimization models considering two main processes for solid waste collection, house by house, and containers. For optimal solid waste collection, the model defines allocation of blocks to collection sectors, determination of the number of visits per collection sector, allocation of operational resources to sectors, definition of optimal paths within each sector, and planning routes, schedules and frequency of visit. Result: the model was delivered to a consulting firm. Project: Regional Food Supply Master Plan. Challenge: to implement a mathematical model to optimize the Bogotá Food Master Plan, that is part of the Bogotá Development Plan. Solution: design and implementation of a mathematical model of the food supply chain, following the principles developed by the Mayor of Bogotá in the Study Plan de Abastecimiento de Alimentos para el Distrito Capital, y la Región Definitiva. The objective of the model is to guarantee the principle of food security, to ensure the availability and quality of food, to reduce the prices of supply, to facilitate the access of all citizens to a more adequate food, and build a supply system that ensures, around a basic basket that, in nutritional terms, allows adequate nutrition for the population. Result: a mathematical model to support cities' food master plans. In the case of Bogotá, the area of influence is not only concentrated in Bogotá, but also covers the 19 municipalities that make up the Sabana de Bogotá. The offer considered 9 production chains: beef, fruver, potato, milk and derivatives, groceries, grains, panela, eggs, and chicken meat. Water Resources Planning and Scheduling Model. Challenge: to develop Water Resource Regional Planning Mathematical Model. Solution: design and implement a mathematical model of stochastic programming, using large-scale optimization technologies, that simulates multi-purpose water resource systems. The model was generally designed for use in medium-term planning activities, or in short-term operations scheduling activities. Result: the model dates from the early 80s, when PDC Ingeniería S.A. used, in Venezuela, the basic model in the following projects: Master Plan for Water Resources Zulia State, 1980, and Irrigation System Design Orituco Guarico, 1979. Project: Flood Control and Power Generation. Challenge: implement a model for the optimization of the design of a project for the use of water resources with a dual purpose, flood control, and electricity generation. Solution: design and implementation of a water resources planning model to be used in the study. Result: the model has been used in several research and consulting projects. The first project was the design of the Sinu River project, to expand the generation capacity of the Ura hydroelectric power plant, carried out for the engineering consulting firm Gomez, Cajao y Asociados, in 2008. Products and experiences in supply chain optimization. HYSCO meets all the software solutions developed by HY, in different areas of supply chain planning and scheduling. The models developed by HY for regional planning are supply chain design, resilient supply chain design, sales and operations planning, industrial production available to promise, research and development, maintenance optimization, supply chain and financial modeling, industrial services optimization, inventories policy, global sourcing optimization, production scheduling, and industrial products available to promise. All models can be part of the hypothalamus of an industrial enterprise. Project: Bavaria Supply Chain Design. Challenge: in 1990, Bavaria hired HY to implement tactical and strategic planning optimization models, using 386-486 Intel CPUs, because its actual models does not run properly in its IBM mainframes. Solution: the models were implemented using the first version of the Bender's multi-level partition and decomposition methodology, that is part of the HYPOTHALAMUS Optimization Expert Robot. Result: Corporate Industrial Planning Decision Support System, PCSI, oriented to strategic and planning models. In 1998, PCSI made it possible to plan a beer supply chain of 18 production plants, 42 bottling lines, and more than 230 SKUs. The models have been used for over 25 years, primarily to support sand-op activities. Implemented in IBM OPL using IBM Plex. Project: Beer Supply Chain Optimization. Challenge: in 2014, SAB Miller, Bavaria, hired HYPOTHALAMUS to upgrade tactical planning optimization models, according to the state-of-the-art of information technologies. Solution: design and implementation of new models, to support sand-op process that includes the modeling of detailed process in the breweries and work shifts in factories. The new model includes detailed modeling of the area of breweries, work shifts in factories, product substitution, the assembly of combos in distribution centers, and reverse logistics of the processing of bottles and baskets. Result: implementation of powered new mathematical models using IBM optimization technologies. Consulting project: Hospital and Surgical Equipment Supply Chain Optimization. Challenge: to solve the planning processes of hospital and surgical equipment and services in SLA, Spanish Latin America, Colombia, Mexico, Chile, Peru, Costa Rica, and Puerto Rico. Solution: design and implementation of a mathematical model, for optimize the planning processes of hospital services of surgical equipment. It produces customer service policies, and optimum inventory levels at each distribution center. Result: a consulting project, using the mathematical model, that proposed customer service policies that estimated a saving in CapEx for inventory of 35%, with respect to the policy plan before the study was carried out. Project: Dairy Supply Chain Optimization. Challenge: to implement tactical planning model, to optimize the supply chain, in the short-medium term, of a large dairy enterprise. Solution: implementation of an optimization model to support the sand-op production activities, including the following type of products: beverages, milk, baby food, desserts, cheeses, cream and butter, and finesse products. The model includes work shifts in factories, and blending processes to prepare the base products. Result: an optimization model to support sand-op production activities. Pharmaceutical Industrial Operations Scheduling Model. Challenge: to implement a scheduling pharmaceutical production plants optimization model. Solution: implementation of an optimization model to scheduling pharmaceutical production factories. The model includes, in detailed formulation, the manufacturing versions, and the lifetime of the raw materials. Result: a scheduling production optimization model. Two versions of the model were delivered, GAMS and C-linked to Plex and Gurobi solvers. Multi-echelon Dynamic Inventory Optimization Model. Challenge: to implement a multi-echelon dynamic inventory optimization model for pharmaceutical distribution. Solution: implementation of an optimization model to generate integrated inventory policies that considers simultaneously multiple products, the distribution network, the consumer centers, sourcing offers, lead times, production and/or distribution, capacity constraints, and work capital constraints. The model is based on a stochastic programming model that can produce Pareto curves for the level of customer service, probability of stock out, versus inventory policy cost. Result: a multi-echelon dynamic inventory optimization model. Delivered to customer. Consulting project: Global Supply Chain Design. Challenge: in 2024, a multi-Latin company hired HYPOTHALAMUS to redesign its global supply chain, in order to determine how best to serve the Latin American and North American markets. Modeling involves the coordination of an international network of raw material plants and end product plants. Solution: applying the new HY methodology for the resilient design of global supply chains, including financial risk management. The model is called GSCD. Result: project in progress. The result will be the implementation and use of the GSCD to determine the best global supply chain for the multi-Latin enterprise. Project: ceramic supply chain optimization. Challenge: To implement tactical planning model to optimize the supply chain in the short-medium term for ceramic industries. Solution: implementation of an optimization model to support the sand-op production activities for sanitary ware. The model includes work shifts in the factories and a detailed simulation of the furnace. It also considers the process of selling and transporting products to different markets. Result: an optimization model to support sand-op production activities including the start, stop of furnace. Project: cement plant advanced planning and scheduling. Challenge: to optimize the energy consumption process in cement factories. Solution: design and implementation of a mathematical optimization model to support planning and scheduling of the production batches, considering as main objective function the reductions of production cost and energy consumption, considering emissions constraints. Result: the model is integrated by 3 nonlinear submodels. Raw materials blending, kiln, and cement mill. Hypothalamus artificial intelligence, HY. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its products and experiences in agroindustries optimization. The table presents the models developed by HY for agro-industrial supply chain optimization. The models are farm planning, agro-industrial available to promise, balanced food replenishment, and animals and vegetables collection. Fruit supply chain optimization. Challenge: to implement an informatic tool to manage the assignment of fruit production to the clients. Solution: design and implementation of a scheduling optimization mathematical model that assign fruit to the clients, considering detailly the bilateral supply contracts, and 2. Scheduling of dispatch the orders and ships, considering the long-term contracts of shipping capacity. To modeling the bilateral contracts, all commercial conditions must be converted in algebraic constraints. Result: an optimization model to support the agro-industrial available to promise process. Fruit supply chain optimization. Challenge: to implement an informatic tool to manage the fruit collection and the dispatch of orders to clients. Solution: design and implementation of a set of mathematical models to agro-industrial available to promise (ATP) process, and design and location of packing plants. The ATP model includes scheduling the collection of fruit in the farms, assignment the fruit production to the client orders, and scheduling of the dispatch of fruit trough pre-scheduled ships. Result: the models were implemented in the client office. The database of the company includes 32 generic brands produced in 50 farms and 113 packing lines, which handle multiple banana farms within Ecuador. Poultry supply demand chain optimization. Challenge: optimize the distribution of turkeys and pigs during the holiday season. Solution: design and implementation of advanced analytics models to forecast the daily demand, and fix the optimal policies inventory throughout its multi-echelon supply chain. Result: a set of models used to advise the client to planning and scheduling the peak season. Hypothalamus artificial intelligence, HY. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its products and experiences in regional planning and public management. Products and experiences in demand chain optimization. If you look at the demand chain, forecasting models must feed into the models of scientific marketing and sales management. These models for tactical planning are: market share optimization, optimizes market attention, considering models that explain the market share of products in the regions. Marketing mix optimization optimizes the distribution of marketing expenditure in the different alternatives, considering the elasticities of the different media, and inventory policies. As a complement, there are the models for operations scheduling. Revenue management, also known as price optimization, determines the dynamic pricing policies of products throughout their life cycle and temporal seasonality. Customer management, artificial intelligence models aimed at determining the behavior of groups of customers or specific people. Product portfolio management, aimed at supporting the sales efforts of salespeople, at times when they must serve customers, and campaign optimization, optimization of product promotion activities, can be considered as part of the marketing mix models. Demand and price forecasting. Challenge, to implement a solution to manage the inventories of a bookstore chain. Solution, design and implementation a set of advanced analytics which involves the characterization of the demand for the final products, determination of optimal minimum inventory levels, and inventory balancing among the distribution centers and the shops. Result, the models were delivered to an integrator company. These models have been used in multiple projects carried out by HYPOTHALAMUS. Market share modeling. Challenge, to design a methodology for the evaluation of the food market potential in Colombia and other potential markets, to optimize the strategic decisions about the marketing global expansion of the company. Solution, design and implementation of 2 statistical models. Bottom-up demand, and market share. An optimization model developed oriented to define the marketing mix decisions related to market share. Result, using Nielsen's syndicated database, the results are used to make strategic decisions about expanding your food demand and supply chain. Salesman portfolio optimization. Challenge, to implement informatic tools to support and optimize the sales operations. Solution, design and implementation of a DSS for management of salesman portfolio. The models include the integration of data mining, machine learning, methodologies, with mathematical programming optimization models. Result, the solution optimizes the supply of products to the traditional channel, and Salesforce portfolio assignments. It was implemented linked to SAP ERP to operate daily, solving more than 128,000 optimization problems each day, in 2006. Driving demand simulation modeling. Challenge, to develop a mathematical model of the technical economic impact of the service model, a dynamic combination of sales resources, promoter, market developer, pre-seller, promoter, shelf racks telecalls, internet, fridges free samples, financing, that organizations use to develop the market via several distribution channels, traditional, shops, specialized, schools, gyms, eating and drinking, self-service, modern channel, street vendors, and home. Solution, design and implementation of a mathematical model of the impact of the services model, that manifests itself in various ways and changes depending on the moment in which a certain service strategy was started. Service strategies correspond to typical combinations of resources. The model solves the question: what is the mix of distribution channel service strategies that must be applied at a certain time, during a certain period, to achieve a certain objective? Result, the model was delivered to an American consulting firm, which provided professional services for a Coca-Cola distributor. Products and experiences in transport and logistics. The table presents the models developed by HYPOTHALAMUS for trucks transport optimization, urban routing, regional routing, mines transport, cash transport, oil products distribution, and less than truckload networks. Regional routing optimization. Challenge, to implement a DSS to management the routing of truck and van type trailers for 2 types of transport services, I, general cargo, any type of cargo of different nature that is transported together, in small quantities, and 2, bulk cargo, transported in a massive, homogeneous way, without packaging, whose usual handling should be carried out in special vehicles. Solution, design and implementation of a set of mathematical models to, I, define routes of client services, and 2, assign trucks and van type trailers to routes. The models include single trucks and empty trailer movements, to coordinate services across multiple regional offices where goods are delivered and or loaded. Result, the optimization models coordinate a transport fleet of more than 400 trucks, 400 trailers, 200 tanks, 500 drivers, and relationships with more than 2,000 other transporters. Gasoline distribution optimization. Challenge, to implement mathematical models for urban routing operations for a third-part user. Solution, design and implementation of routing models for gas tankers in urban/rural space. It includes time windows service for each customer, limited number of loading racks in the load bays, inventory levels on tanks, and preparation time for change in product loaded. Result, the optimization model handles 250 orders daily average, 169 clients or nodes, 139 trucks, 7 loading bays, loading racks, 3 shifts. Distribution planning and propane gas gathering. Challenge: to implement mathematical models for distribution planning and propane gas gathering. Solution: design and implementation of a mathematical model for distribution planning and propane gas gathering. It is aimed at supporting the weekly and daily programming and operational rescheduling of trucks dispatch. The modeling hypotheses are as follows. Fleet of vehicles consisting of multiple type of trucks and multiple type of LPG trailers. Trucks can be moved with or without trailers. A truck can tow some type of LPG trailer. LPG trailers can be dispatched with or without charge. Vehicles move between nodes, or terminals. In the nodes there may be demands that must be met or purchases that enter LPG into the system. In the nodes there may be demands that must be met or purchases that enter LPG into the system, and LPG storage tanks may exist in the nodes. Result: the models were delivered to the client. Products and experiences in multimodal transport. The table presents the models developed by HY for multimodal transport systems optimization. Port operations, vessel and industrial facilities coordination, rail operation, and fishing operations. Routing boats in fishing transport systems. Challenge: to develop and implemented a model for planning and scheduling the allocation of fishing boats to process plants. Solution: design and implementation of a set of optimization models for planning and scheduling the allocation of fishing boats to process plants. The decisions supported by the models are: number of vessels to be departed daily, fishing destination by vessel, quantity forecasted, tons, of fishing per vessel, assigned return plant per vessel including its scheduling, times, arrival, start downloading, finish downloading, quantity forecasted of fish purchase from third parties per day. The modeling includes the vessel speed navigation, fish quality degradation as a function of the time on the vessel, and future fish flour blending considering inventories in the plants and the commercial commitments. Result: implementation made jointly with a fishing company, mainly engaged in the business of fishmeal. The fishing company operates, during the fishing season, 100 daily average boats, 8 ports, process plants, with 2 types of production technologies. Port operations optimization. Challenge: to implement tactical planning and scheduling models to optimize its operations and commercial services. Solution: implementation of a set of optimization models for I. the definition of operations timetable, and 2. the allocation of ships to docks and cranes to ships, to optimize the management of shipping services, in the 2 terminals of the Port of Cartagena. Result: the mathematical models allowed to optimize operations of the port for I. planning terminal services assignments, 2. planning big events in the port, and 3. analysis of commercial opportunities. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.